Hi, my name is Claude Roux. I'm a professor of forensic science and the director of the Center for Forensic Science at UTS. I'm also the president of the International Association of Forensic Sciences. It's my pleasure to introduce you to someone who has been a pioneer in the indium zinc formulation, commonly referred to as the Australian formula. Chris Lennard is a professor of forensic science at Western Sydney University. His main area of research is finger mark detection techniques. He also covers a number of areas of forensic science, including explosive analysis and in-field detection of forensic traces. For over 12 years, Chris also worked as a forensic scientist with the Australian Federal Police. Here is in conversation with Dr. Sunil Badami, a Doctor of Creative Arts from the University of Technology, Sydney. This is the first in our two-part series that seeks to combine academic and industry professionals from both the humanities and science disciplines in conversation. I hope you enjoy.
So in terms of fingerprint forensics technology, what have been some of the big developments in the last few years?
So some of the advancements over the last few years have certainly included better techniques for detecting finger marks on certain surfaces. A big advancement on paper surfaces, for example, was involving a chemical called indane-dione, and some research that we did here in Australia that led to a new formulation that has basically made the technique the best single method for developing finger marks on paper. So it's now universally accepted. The formulation that was originally proposed in Australia is now the one that is recommended as the go-to method on paper surfaces.
You were instrumental in that early research in regards to what's now known as the Australian formula. How did you and your colleagues discover it?
It was actually a collaborative effort. It was back when I was still with the Australian Federal Police, and we were undertaking collaborative research with the University of Technology, Sydney. And we had some research students working on evaluating indane-dione as a method for finger mark detection on paper. This method, indane-dione, had been proposed by researchers overseas, but various countries had evaluated the method, and some countries found that it worked well, other countries found that it didn't. And there was some question mark in terms of whether or not it should replace some of the existing methods at the time. In research that we undertook in the laboratories at the AFP in Canberra, we were playing around with adding metal salts to the indane-dione solution. With other methods, adding metal salts can actually change the colour of the reaction product with certain chemicals that we use for finger mark detection. For a couple of reasons, we decided to add metal salt to the indane-dione formulation, and we found that it dramatically improved the result, and that led to a range of different research projects to evaluate what became the indane-dione zinc formulation and to try and work out why the addition of a zinc salt made such an improvement to the reagent. And through a PhD project that was undertaken at UTS, it was determined that the addition of the zinc salt worked as a form of catalyst and actually pushed the reaction towards the highly fluorescent product that is the basis behind this detection method. So it was really just thought at the time that adding in a salt solution to the formulation might be something interesting to investigate, and it actually led to the technique that we have today, referred to as indane-dione zinc.
Why did you come to the decision to use salt or mineral salts in the solution as opposed to any other kind of agent? How did you get to that point where you were going to use salt?
The addition of a zinc salt was based on earlier research, and some of it dating back to my own PhD in the mid-1980s, where we knew that the addition of a zinc salt to a fingerprint that's been developed with a reagent called ninhydrin actually changed the colour of the fingerprint and gave some weak fluorescence. And we thought that if we used it in the case of indane-dione, then maybe we see a colour change, maybe we see some improved luminescence. What we did see is not really a colour change, but rather a significant improvement in luminescence, and a technique that most countries now agree is the best method we currently have available for detecting finger marks on paper.
What is indane-dione?
So indane-dione is a chemical reagent. It's an organic compound that reacts with amino acids. Now, in the sweat that you have on your hands, that includes some amino acids. Now, amino acids come from your diet. In your diet, you're eating some protein. Your body is metabolizing the protein, breaking it down, and byproducts from this breakdown are amino acids. Some of the amino acids are needed by your body for certain bodily functions. The excess amino acids are secreted through the sweat on your hands. So when you touch a surface, for example, a sheet of paper, you are depositing a finger mark, and in that finger mark you have amino acids. We can apply a chemical reagent that reacts with amino acids. So the conventional method is using a chemical called ninhydrin. Ninhydrin reacts with amino acids and gives a purple colour. So we can develop finger marks using ninhydrin. A much more sensitive method with the indane dione zinc method, which gives a very, very strong fluorescence and is much more sensitive than ninhydrin. But indane dione, again, is reacting with the amino acids to give a brightly fluorescent finger mark when we are developing fingerprints on paper.
Take us back to that moment where you finally realised that zinc salts were going to work, that you'd had this moment of breakthrough after trying to work out how to use indane dione. Where did this moment happen? Was it in the shower? Were you walking to work? Were you in the lab?
So that moment actually occurred when I was at work at the AFP. I was working with a colleague, Milutin Stojlovic, who was doing some laboratory work on this particular day. And I'd asked him to try using zinc treatment after developing indane dione prints. He'd done that. He said, yes, I can develop the finger marks with indane dione. I can then do a second step where I treat the indane dione prints with the zinc solution. And I asked him, well, what difference did that make? He said, well, the colour didn't really change, but the luminescence was slightly better. And I said to him, well, why do it in two steps? Why don't you just go back and try it by adding the zinc directly to the indane dione solution? And he came back an hour later and he said, I've tried that, and he said the results are amazing. It doesn't give a slight increase in luminescence, it's significant. And I said, fine, we might be onto something there. And I asked him to go and do some more work on it, and we were able to confirm that the addition of the zinc directly into the indane dione solution completely changed the technique from a technique that was lacked a little bit of reproducibility to one that was highly reliable and as I said earlier, is now the best technique we have available on paper.
What did you do to celebrate once you realised you'd come across this amazing new method?
There wasn't really any celebration as such. As scientists, you've got to validate the result. So it actually meant getting some students to do more work to confirm that we saw this improvement, also to investigate why we got this improvement. It wasn't one moment where we decided to celebrate. It was more building on that initial discovery.
How long did it take between that moment you and Milan finally saw this luminescence, the students' projects, and its final acceptance and employment by law enforcement around the world?
From the moment we started using the indane dione zinc formulation, I would say it's probably about 12 months before we had enough to publish the results in a journal article. Probably another 12 months for word to get out via a group called the International Fingerprint Research Group, a group that's made up of representatives from various countries. A number of those representatives then replicated our work and confirmed the effect that zinc was having. Some groups further optimised the formulation, and I think every year since then there have been more and more studies done that have just continued to confirm that the addition of the zinc salt directly into the indane dione formulation, that this was without doubt the best method we currently had available. So this was a process over many years, going from acceptance within the AFP laboratory to acceptance nationally, and then finally, after a number of years, acceptance internationally.
Did you expect that this discovery would have such an impact and influence around the world?
I think at the time you never realise what impact it might have. We certainly felt that we had a formulation that had overcome some of the issues discovered overseas. We were confident that research groups around the world would find the same results, but until those extra studies have been done and the results published, you never really know. Again, it's a fairly slow process of getting the research replicated at various locations around the world and finally confirming that this was going to have a major effect operationally. And by that I mean that the labs that have now moved to indane dione zinc as their main detection method on paper are now discovering far more finger marks in casework. And discovering more finger marks means that we have a greater opportunity to solve more crime. It's very hard to predict in advance that it's going to have that effect, but in this case, it certainly has had a dramatic effect internationally on success rates when developing finger marks on paper.
What's the difference between fingerprints and finger marks, and why do forensic scientists call fingerprints finger marks?
Yeah, that's an interesting one in that traditionally fingerprints was the common term used universally. More recently, we've tried to distinguish between finger marks and fingerprints. Fingerprints being a very accurate representation of the fingerprint from the skin in the form of either an inked fingerprint. So if you're arrested and your fingerprints are taken, you will get inked impressions recorded on a sheet of paper that will then get scanned and put on the database. Or your fingerprints may be taken using a form of scanner where you place your fingers down on a sheet of glass, and from underneath a scanner will record your fingerprints. So the term fingerprint is for the accurate representation of your fingerprints in a form that can be used on a database, for example. So fingerprints are good quality and they're used as a reference when searching databases. Finger marks are the marks left at crime scenes or on other items connected to a crime, and these are the chance impressions when individuals touch surfaces with their bare hands. Finger marks can vary in quality. They can go from quite poor quality that are useless for identification purposes up to high quality finger marks that provide obviously a good opportunity to identify the donor of those finger marks. So finger marks are the chance impressions in relation to a crime from unknown individuals, whereas fingerprints are the high-quality reference prints that are used for reference purposes and are placed on databases.
So how reliable is the Australian formula in detecting finger marks at a crime scene or on evidence?
Okay, with the Australian formula indane zinc, it is only for what we call porous surfaces, so things like paper, cardboard, untreated wood, and all of the studies have shown that in comparison with all other techniques that could be used on these surfaces, this is the most sensitive technique we have available. So it has become the go-to method for porous surfaces, not only here in Australia, but in most countries overseas.
So how do you balance ethical or privacy concerns with solving or preventing crime with forensics?
Obviously, we want to identify offenders and basically take them out of circulation so they can't re-offend. And I don't think that any normal member of the public would complain what techniques might have been used to identify the actual offender of a particular crime. They certainly wouldn't want that offender not to be found and to go on and to re-offend. But I think it's a fine line in terms of some of the investigative techniques that could be used and the associated ethics. And I think this is an ongoing debate around the world as we speak. Things like using publicly available DNA databases and whether or not law enforcement should be accessing these databases to try and determine the identity of a particular individual. And I think the Golden State Killer investigation is a good example of that. It looks like they have managed to identify the offender through the use of these databases. I think the dilemma is that the databases were established by members of the public who were essentially uploading their DNA profiles, not knowing that at a future time law enforcement might use these profiles for some other application, for something that wasn't originally intended. So there are certainly some ethical issues. I don't have a clear answer to it. There needs to be a balance between the privacy concerns but also the public good that can come from more effective investigations to identify victims of particularly serious crime.
Where is the indane Australian formula used around the world?
The indane zinc formulation, as far as I'm aware, is now used fairly universally now around the world. So I think all of the major fingerprint bureaus worldwide, particularly the ones connected to the International Fingerprint Research Group, have now adopted indane zinc as their go-to operational method. There may still be some labs around the world that have not yet adopted this method, but I think it's only a matter of time before they also move over to this formulation. And they will find, like others have found, that it will improve their success rate when detecting finger marks on paper.
What are the biggest challenges facing law enforcement and forensics today? I'm thinking about, for example, the reliability or ensuring reliability or accuracy in forensics at the moment.
Yeah, I think there's been a lot of criticisms of various fields of forensic science and claims that some of these fields lack scientific foundations or haven't been properly validated. I think we need to be well aware that any methods that we develop and apply operationally need to be appropriately validated. We need to be able to document the reliability of these methods before they're used operationally. And that will be an ongoing challenge. As new technologies evolve, we need to be able to demonstrate their reliability. So that will remain a critical issue for any of the current techniques we use, but any future methods that we also implement.
What do you see as the next big development in detecting finger marks?
In terms of the next big development, that's really difficult to say. A lot of research groups around the world are investigating nanotechnology. So this is investigating particles, for example, on the nanometer scale. So we're talking extremely small particles. If we can find the right chemical structure for these nanoparticles and develop ways that these particles can be attracted to finger marks in a very specific way, then we might be able to come up with a more sensitive, more specific detection method. So certainly nanotechnology or the use of nanoparticles is a promising area. At this point, we don't yet have a nanoparticle-based method that could replace one of our conventional methods, but who knows? There could be a eureka moment by one of the research groups working in this area, and it could lead to the next big development. I think another area worth mentioning is the chemical analysis of finger marks. Not only trying to detect and record a finger mark, but trying to come up with information on the chemical composition. What is in the finger mark could indicate, for example, what the individual recently touched. So in the finger mark, we might have illicit drugs. We might have explosive residues. We might have residues of something they've recently eaten. We might find nicotine showing us that they were a smoker, or metabolites from an illicit drug. So we could get lifestyle information, recent activity information on the individual that deposited the finger mark. And there are various methods being investigated, for example, using mass spectroscopy to get a chemical composition of a finger mark. So this could be useful in a case where we have a finger mark, but we don't have a matching fingerprint in our database or in our pool of suspects. So at that point, using normal processes, there's nowhere to take the information. But if we can get some additional information on the chemical composition, it could tell us the gender, for example, of the individual, what they've recently touched, what they've recently consumed. So information that could assist with the investigation. So that's another, I think, promising area being researched at the moment.
Thanks for listening to this conversation and bonus sets of the History Lab episode, A Close Match. If you haven't already, go and check out our other In Conversation bonus episode with Dr. Simon Walsh, the National Manager of Specialist Operations at the Australian Federal Police, to hear about his take on the future of forensic science.
It's really looking at the way that society is changing, looking at the big impacts that are driving those changes. And it doesn't take very much for you then to think about ways in which that might impact the criminal environment or impact communities.
You can find out more about the Centre for Forensic Science at the University of Technology, Sydney, and hear the latest episode of History Lab, A Close Match, where we examine how everything leaves a trace. Just head to historylab.net.